Let's start with our discussion on lower triangular matrix. Okay. So what does it mean by lower triangular matrix? So we will have a look at the mathematical definition first, and then afterwards we will have a look at the definition in words. So mathematical definition, have a look. A square matrix A equal to Aij is called lower triangular matrix if and only if. So obviously it must be a square matrix. So you can have an example over here. This is a square matrix because it has three rows, one, two, three rows, and three columns, one, two, three columns. Okay. So three rows and three columns. It is a square matrix. Now it will be a lower triangular matrix if and only if. You can have a look. Aij equal to 0 for all I is smaller than j. So corresponding to these three elements which I am marking, this element is corresponding to A12. Okay. Then this particular element is corresponding to A13. Okay. And this particular element is corresponding to A23. Okay. So this is corresponding to A23, this is corresponding to A13, and this is corresponding to A12. Okay. So have a look. I is smaller than j. For this element, and this element, I is smaller than j. So such elements where I is smaller than j, those elements are equal to 0. So you can have a look. These three elements are equal to 0 because over here I is smaller than j. Over here I is greater than j. Okay. And at the diagonals I is equal to j. At the diagonal elements I is equal to j. For for this area I is smaller than j. For this area I is smaller than j, and for this area I is greater than j. Okay. So above the elements which are present above the principal diagonal, this is the principal diagonal, and elements present above the principal diagonal. So those elements which are present above the principal diagonal, those have I is smaller than 0. I is smaller than j. Okay. I is smaller than j for elements above the principal diagonal, and I is greater than j. I is greater than j for elements below principal diagonal. Okay. So I is smaller than j for elements above principal diagonal. Okay. And I is greater than j for elements below the principal diagonal. Okay. So this is the thing. So in this manner, in words, how to mention this in words? In words we can say that all the elements above the principal diagonal are equal to 0. All the elements above the principal diagonal, this is the principal diagonal, and these three elements which I have shown, this particular element, this element, and this element, these are elements above the principal diagonal. So how to write the definition method in terms of words? How to write it? In terms of words, we can write something like this. A square matrix is called lower triangular matrix if all the elements above the principal diagonal are equal to 0. Okay. So all the elements above the principal diagonal, you can have a look. Just a second. Okay. So all the elements above the principal diagonal are equal to 0. Now why is it being called as lower triangular matrix? So it is being called as lower triangular matrix because a triangle of numbers is being formed in the downward side of the matrix. In the downward side of the matrix, a triangle of numbers is being formed. Okay. So it is being called as lower triangular matrix because in the lower side of the matrix, a triangle of numbers is being formed at the lower side of the matrix. So that is why it is being called as lower triangular matrix. Okay. So this is the thing. Now there is an amazing fact over here. A diagonal matrix is both upper and lower triangular matrix. Now let us understand why. Why is a diagonal matrix both upper and lower triangular matrix? Let us understand the reason behind it. So suppose I have something like this. Okay. So this is clearly a diagonal matrix. What is definition of diagonal matrix? I have already told you. This is a diagonal matrix because only diagonal elements are present, all the other elements are 0. Okay, so clearly this is an example of diagonal element, a diagonal matrix. Okay, diagonal matrix. This is an example of diagonal matrix. Okay. Now it is saying that diagonal matrix is both upper and lower triangular matrix. So let us apply the conditions. let us apply the conditions. For upper triangular matrix, for I equal to j, for I greater than j, okay, for I greater than j, okay, this area has I greater than j, this particular area has I greater than j, and this particular area which I am marking with green color, this particular area has I smaller than j, okay. So the red colored area, okay, let me erase this first, okay, let me erase this. So let us have a look, okay. So I is smaller than j for green area, and I is greater than j for brown area, okay. For brown area, for brown area I is greater than j, and for green area I is smaller than j, okay. So this is the thing. Now what is a upper triangular matrix? Upper triangular matrix definition says something like this, okay. That for I greater than j the element is 0, okay. So for upper triangular matrix, what is the definition? For upper triangular matrix, these elements must be 0. For upper triangular matrix, these elements must be 0, so they are 0. And for lower triangular matrix, these elements must be 0, so they are also 0. So diagonal matrix is clearly an upper triangular matrix also and a lower triangular matrix also, because for I smaller than j also the element will be 0, and for I greater than j also the element will be 0, okay. So only diagonal elements are present, okay. So I is smaller than j and covered, and I is greater than j covered, so all those elements are 0. So clearly this diagonal matrix is clearly both an upper triangular matrix also and also a lower triangular matrix. It is both upper and lower triangular matrix. So a diagonal matrix is both upper and lower triangular matrix. If you apply the definition, you can certainly see this. If you apply the definition, you can clearly see this. Thank you very much.